Hello and welcome to this video in the series on integrated pest management, focusing on disease control in cereals. And in this episode we're going to be thinking about the timing of fungicide applications when we need to treat. So at the moment I'm dodging the April showers in North Yorkshire, and April at the start of stem extension has become accepted as a key time for fungicide treatment in wheat and in barley, and it's known generally as the T1 timing. In this video we're going to explore how these timings came about and whether they're really the most efficient times to be applying fungicides. So nobody likes applying fungicides, but if we're going to do so, we should at least make sure they're going to be effective. In this episode of the series on integrated pest management, we're going to focus on the question, when is it most efficient to treat with fungicide if we need to treat? This is data from the Pest and Disease survey of UK wheat crops over a 15-year period. So this is from several thousand crops. And we can see the key timings of fungicide applications that were made to those crops. And there are 4 key timings which have become known as T0, T1, T2 and T3. T0s, as we can see here, typically applied around end of March, beginning of April. T1, usually around mid to late April. T2, the flagleaf spray, typically mid to late May. And T3, an ES spray in the middle of June. So we're going to think about whether these are actually the most efficient timings and how these timings came about. In a previous video in this series, we addressed the question of which parts of the crop canopy need protecting from disease and when. And we thought about, in barley particularly, the need to protect the formation of sink capacity through protecting tiller production and survival and ear growth. And in wheat, principally focusing on protecting canopy duration and the source capacity for storing carbohydrate in the grain during grain filling. So the leaves that we're going to try to protect are quite different in barley and wheat, but the principles we're going to use to protect them are the same. We also looked in an earlier video at the pathogen life cycle, in this case for Septoria tritici. We looked at how the spores arrive on the leaf surface and infect. In the case of Septoria, that they penetrate into the leaf, they grow in between the cells of the leaf as a period of symptomless growth in a period called the latent period. And then after a period of a number of days, we get symptom expression that we can see externally, and that coincides with the start of spore production. So now we're going to think about that in relation to fungicide treatment and fungicide timing, and we'll do that in diagrammatic form. This is a set of images taken from the Wheat and Barley Disease Management Guide from the AHDB. On the left-hand side, we can see spores landing on a newly emerged leaf. In the second image, the fungus has penetrated into the leaf and is starting to grow internally. And during this phase, fungicides can provide effective control. However, we reach a certain point during the latent period when, even though there's still no visible symptoms visible on that leaf, the fungal growth is now too advanced for fungicides to be able to control it, and subsequently symptoms appear on the leaf, spores are produced, and go on to infect leaves typically above in the canopy. So if we look at the arrows towards the bottom of the diagram, we can see a period when fungicides are generally effective in protecting against spores infecting or at eradicating infections that have already occurred, and then a period when later in the latent period fungicides are no longer effective. And we give these different periods of time different labels. So we talk in the period when the leaf has just emerged and before spores start to land on it, or as they're just starting to land on it, as a period of protectant control from a fungicide. And then once the fungus has penetrated into the leaf, if we have a systemic fungicide which is also able to penetrate into the leaf, we can have a period of eradicant or curative control. And it's important to note that when we talk about curative here, we're only talking about curing infections that are not yet visible. We can't control infections that have gone beyond that point. So, although most fungicides can provide both protective and eradicant control, there's still quite a contrast in the effectiveness of that control. This is data taken from the fungicide performance trials over a 3-year period, and I've picked out data from 3 of the most recently introduced systemic single-site acting fungicides, mefentrifluconazole, which is an azole, fenpicoxamide, which is a QII fungicide, and isoflucipram, which is an SDHI fungicide, so different modes of action. And in every case, this is data from a very challenging situation with a single fungicide application, usually against quite severe disease pressure with a full label dose. And we can see that the level of protectant control that's obtained from these new products is really very effective despite that high disease pressure and difficult challenge. But if those fungicides are applied in eradicant situations when there's latent lesions, the level of efficacy that's obtained is still very useful, but is significantly lower. So let's just look at that now in a bit more detail in relation to spray timing. Oh, and the other point to make here is the contrast with the protectant multi-site acting fungicide Folpet, which, as the name suggests, is purely a protectant fungicide. It provides just short of 40% control in a protectant situation, but you can see in an eradicant situation it's ineffective. So spray timing for that product is particularly important. We've seen this diagram in one of the earlier videos, but we'll now relate it to spray timing. So the T0 application is really a kind of insurance spray early in the season before the upper 3 leaves of the canopy emerge. And here we're thinking about winter wheat particularly, where the aim is to protect the upper 3 leaves of the canopy during the grain filling period. So the T1 application is targeted at the time when leaf 3 down the canopy is just emerged, and it's providing protection on leaf 3 against the first spores that are going to arrive after that leaf has emerged. It will also provide some forward protectant activity against spores arriving on leaf 2 later on in the growth of the crop. The T2 application is applied just as the flag leaf has fully emerged at growth stage 39, and again it's providing protection of the flag leaf, which is very important for light interception, as we saw previously, against the first spores arriving on that leaf. And it's also providing control of latent infections that are as yet symptomless on leaf 2, which may have become infected up to about 10 or 14 days previously. And then the T3 spray is applied as the ear is fully emerged, and that's there to top up the foliar disease control and also to protect against some ear diseases where necessary. And I've put the T0 and the T3 in brackets because the T1 and T2 timings are typically cost effective in wheat crops in the UK, whereas the T0 and T3 timings are more sporadically cost effective and depend on disease pressure. Typically, for example, early yellow rust epidemics requiring control at T0, or severe Septoria pressure or Fusarium ear blight pressure after the ear has emerged. Now, as we can see here, these timings are related to leaf emergence, and we've also put growth stages on here. The difficulty is that depending on sowing date and winter temperatures, wheat can produce varying numbers of leaves. So when you get to growth stage 32 or second node, the leaf that is emerging might be leaf 3, or it could be a different leaf. And what we're interested in is which leaf has emerged. So to be certain which leaf you're actually protecting in order to get the timing right, we need to dissect the plant. Fortunately, this is a type of dissection that can be done with the bare hands. It can be done out in the field or on the kitchen table, and typically only takes a few minutes once you've got the hang of it. So let's just take a look at that. So this was a wheat shoot that I took out of a field yesterday in Yorkshire, and what I've done is just snapped off the remainder of the shoot below the highest node that I could feel in the stem. What I've then done is very carefully felt down the leaf sheath that extends from the point where the outermost leaf attaches to the stem, and carefully sort of unfurled that leaf sheath back until I could remove that leaf and its attached sheath. And in this case, that turned out to be what will eventually be leaf 4, and you can see that that leaf has just fully emerged. Once I've removed that, what I can see inside is the leaf and the sheath of the next leaf down that's in the process of emerging and was just starting to poke out, which in this case was leaf 3. If I very carefully get hold of that leaf and start to unfurl it and unfurl its leaf sheath, I can peel that leaf away as well. And what I can then find sitting inside that is the small leaf that will eventually become leaf 2 that has yet to start emerging. Now this is where it gets ticklish. You really need to be careful, particularly if your fingers are like pork sausages. You need to very gently unfurl that leaf, and if you do it carefully, what you'll find underneath is the final leaf or flag leaf, which in this particular case was still very tiny. And inside that leaf you'll find the very small ear, which you can actually see quite reasonably. So two things to be careful about. The first thing is that as you peel these leaves away, it's very easy to peel the flag leaf away and lose it and not see it at all. and that results in you miscounting your leaves by one. And the second thing is we're just illustrating here that the ear and the attachment of all these leaves will always be above the uppermost node that you can feel on the stem if you just run your fingers up it. So it's safe to snap off the stem and all the leaves that sit below that node before you start, which makes it easier. Okay, so we're certain about which leaf we're now dealing with. Now let's have a look at what leaf emergence does to the efficiency of fungicide treatment. So let's go from the kind of microscopic to the big scale. Let's imagine you're daft enough to set up an enormous field trial with hundreds of replicated plots in it, and each individual set of replicated plots receives one spray which will be at one particular timing and one particular dose, which may be no dose at all, or quarter, or half, or 3/4, or full label in maximum individual dose. And different plots will receive that single spray at different timings, which are a week apart over an 8-week period. And then suppose you're daft enough to go back into that field every week and assess the amount of disease on every single leaf layer and add all those disease assessments up, which gives you what's called an area under the disease progress curve, or AUDPC, which is a measure of the amount of disease severity in that set of plots. If you do all that, then what you end up with is the little black dots on this diagram. So there's one little black dot representing the disease severity for every spray timing and every dose. And you can then fit a mathematical function that describes a surface that describes those data. So if we look at the left-hand diagram, if we imagine we looked at it from the left-hand side, what you would see is, in this case, which is for eventual leaf 2, the early sprays have rather little effect. As we spray later and later, those sprays get more and more effective, and we start to see a dose response curve, which you can sort of run your eye down the bottom of this valley. You can see as a response curve of increasing effectiveness with increasing dose. And then as we get later and later, the effectiveness of control gets less and less again. So the left-hand side of this represents extreme protectant control, and the early sprays are really spraying too early to have any useful protective effect on this leaf. And the later treatments are the extremes of curative treatment, and obviously if we go too late, symptoms have already formed and we can't control the disease. But there's a sweet spot in the middle. Now let's imagine we rotate that three-dimensional diagram and look down on it, and we imagine it's a valley on an Ordnance Survey map, and we're going to plot contours of that valley, and that's what we're showing in the right-hand diagram. So these are now contours of percentage control. So at the top we've got 10% control contours, then 20, then 30%, then 40% control, 50% control and 60% control. And again, this is a really challenging situation because it's just one treatment. So we're not going to obtain really effective control with one treatment against severe disease pressure. So the first point that comes out of this is there's clearly an optimum timing for treatment of this particular leaf, which was between spray timings 4 and 5, which, if you remember, these sprays were applied over an 8-week period in total, so that's between week 4 and week 5 from when we started spraying. The other thing that you can see from this is the width of the spray window within which we can obtain a certain level of control. And what you can see is that actually increasing the dose from half dose to full dose buys you a few extra days of protective control on the left and a few extra days of curative control on the right, but it only buys you relatively few extra days of spray window. So regardless of dose, timing remains really critical. So that's for one leaf layer in the canopy. If we look at the upper 3 leaves in the canopy from the same set of experiments, and we got very similar patterns of effect across sites and seasons doing this experiment. What we can see is that the optimum timing for leaf 3 was earlier, as you might expect, because that leaf comes out earlier. So it was the optimum time just after week 2 here. The optimum time for leaf 2 was about 10 to 14 days later, because that leaf came out 10 to 14 days later. And the optimum time for the flag leaf was again about 14 days later, because the leaf came out about 14 days later. So this set of experiments was what led to the diagram that was in the first of the wheat and barley disease management guides published by HGCA, which became AHDB, and led to this diagram about the optimum spray timings for controlling disease on the top 3 leaves. And what we can see is that the T1 timing at the emergence of leaf 3 is providing optimal control on leaf 3 and good forwards protection on leaf 2, and the T2 timing is optimal for controlling disease on the flag leaf and providing useful eradicant control on leaf 2. Therefore, these 2 treatments are combined to provide control of the critical leaves on wheat. That leaves us to consider the T3 spray timing, which can have a rather different focus. Again, the timing of this is critical, which of course is difficult with UK weather. But ideally, if we treat at growth stage 59 when the ears have just fully emerged but have not yet flowered, that gives us optimal timing to top up the foliar disease control, but is not effective at protecting against Fusarium ear blight and other ear diseases. For that purpose, the optimal timing is early flowering, when we can see anthers emerging from the lower and middle part of the ear. By the time we're seeing anthers emerging from all across the ear right up to the top, flowering is actually pretty much over and it's too late to obtain effective control. So what can we conclude from all this about when it's most efficient to treat? So the first obvious thing is only treat if you need to. These spray timings are not mandatory. They're there as efficient times to treat if it's necessary. For wheat, the timings are determined by emergence of the top 3 leaves. We can't assess that accurately by nodal growth stage. We need to dissect, but that's relatively quick and simple. And the T1 and T2 timings are usually cost effective, and the T0 and T3 timings are sometimes cost effective, depending on disease pressure and the resistance of the variety. In barley, the situation is difficult and different. We're trying to protect sink formation, and for that, the T1 timing earlier in the season is critical. Most cereal fungicides now, with the exception of Folpet, are systemic. They give both protectant and eradicant or curative control, but nevertheless, protective treatment at the optimum timing is more dose efficient than applying curatively. And as we saw from the surfaces, treating too early actually loses as much efficiency as treating too late. And a higher dose, clearly within the maximum individual dose permitted on the label, only extends the spray window by a few days. And this last point we'll return to in a future video. Increasing dose to compensate for poor spray timing will help to maintain control, but actually it may not be cost effective to increase dose, which may seem counterintuitive. We'll return to the reasons for that in a future video.